So good morning and welcome, everybody. My name is Carol Zabin. I'm with the UC Berkeley Labor Center, and our beloved chair, Ken Jacobs, is homesick with the flu, but we don't think it's S1N1, whatever. It's just something that he couldn't make it, so I'll be doing the welcome. And we're very, very pleased to be here after a long period of planning, and we're really excited about the turnout and the cross-section of people here. Right now, we know that climate change legislation is being hotly debated in Congress. We're getting prepared for the Copenhagen meetings in December, the international negotiations, and here in California, though we've passed climate change policy, there's a lot of decisions still to be made on the exact policy design, particularly with regard to the cap-and-trade system. So this is a really timely conference. We're really pleased to have folks from labor, folks from business, government, community groups, environmental justice organizations, and we're looking forward to a really productive day with a lot of interchange and hopefully bringing you speakers who are deeply engaged in this issue, some of the latest cutting-edge research and insight into the political process. We want to welcome both those who are new to climate change policy. We know it's a steep learning curve. I know personally, because it was only about a year ago that I became enmeshed in this big area, as well as those who have been enmeshed for years and are experts in the field. We really think it's important to broaden the engagement of unions and of other groups in this debate and in this set of decisions because it will affect our economy tremendously. It's a historic opportunity to deal with this critical issue of saving our planet, but also to be able to shape an economic restructuring so that it's a good jobs economy. I'd like to acknowledge our co-sponsors and our funders, the Apollo Alliance, the California Labor Federation's Workforce and Economic Development Program, the State Building and Construction Trades Council of California, the UC Berkeley Don Weil Center on Employment in the Green Economy, the Energy Foundation, the Environmental Justice and Climate Change Initiative, the French-American Charitable Trust, PG&E, and Western Climate Advocates Network. I also want to say this event is certified as a green event by the UC Berkeley Sustainability Office, so please recycle. There's bins around them. Please use them, and also leave your name tags so we can recycle them. Air travel for the conference was offset through the UC Berkeley Climate Action Partnership, which is working to reduce greenhouse gas emissions here on campus. I want to also thank the conference organizers, Teresa Short, Cheryl Brown, and Sandra Laughlin, and especially Andrea Buffa, who really pulled this together. So let's give a hand to Andrea, who's right there. We'd like to launch this with a welcome from two really wonderful labor leaders that we have in the state. I'm first going to introduce Art Pulaski, who's the Executive Secretary-Treasurer of the California Labor Federation. The Federation represents 2.1 million members of 1,200 unions in manufacturing, public sector, construction, service, etc. Under Art's leadership, the Federation has helped to elect worker-friendly legislators and passed important laws protecting workers and pushing good jobs. Art has also taken leadership in the Apollo Alliance and in climate change engagement by unions on a lot of levels. Art formed a committee of his executive council to address climate change, and under his leadership, unions engaged in the AB 32 scoping plan implementation process here in California. Under his leadership, his Workforce and Economic Development Program has been very active in promoting training for the new green economy and building labor management partnerships so that unions can be actively engaged in reconstructing and constructing our clean energy economy. So with that, Art, thank you.
Thank you. Thank you, Carol. I'm delighted and honored to be here with you this timely moment. I'm coughing. I do not have that flu either. It's just some gunk that I have, so it's okay to shake my hand or sit next to me. Happy, by the way, Cinco de Mayo Day, in honor of the great independence of our neighbors to the south. At lunchtime, free beer, Tecate beer, will be distributed by the speaker that follows me, the head of the California Building Trades Council. So thank you to Bob Balgenorth in advance. No cost to the university, of course. And you'll find then that the afternoon speakers will be really terrific in particular. This is, by the way, an impressive lineup, a very impressive lineup that I see on the agenda. And I'm glad that you all have taken the time to be with us here today. We are on the verge of a great transition. And I find it myself almost dizzying that overnight, a few months ago, we took a 180-degree turn in the policy of America, where previously we had no sensibilities related to science on climate policy, to a new administration that actually bases climate policy on irrefutable science. And so we're off on a new direction now, and that's really exciting for us, although I want to raise some issues and some concerns, particularly to the workforce, in terms of how we manage the new green economy. And I want to say that traditionally, on behalf of, I think, both working people and also environmentalists, new industrial change, new industrial economies have basically left us behind the curve. And this time, we want to think about how we get ahead of the curve on the new emerging green economy. A couple of issues, a couple of observations. And the first is that workers and the disadvantaged disproportionately have bared the hazards and the cost of industrial pollution. Second, of three things. Second, that high carbon-emitting sectors of the economy tend to have the higher union density. And so as we face this industrial change, this new economy, what does that do to the workforce? And third, working families and the disadvantaged also bear the higher costs of economic transition and also rising energy costs. So in order to get ahead of this curve for us, we need to really see, I think, a conversion of the economic justice of the workforce and environmental justice community. I want to paraphrase two great people. The first is Cesar Chavez, who said, "It isn't the form that's going to make the difference. It isn't the rule or the procedure or the ideology that's going to make the difference, but it's human beings that will make the difference." Yesterday, I was with Carl Pope, the head of the Sierra Club, who said that we're not going to have environmental justice until, with this new economy, we have a more highly skilled workforce. He talked about, and it was fascinating to me, that he talked about how some in this new green economy are looking for an unskilled workforce because they want to push wages lower. But as a result of having an unskilled workforce, and he went back through history, of the Industrial Revolution and talked about how an unskilled workforce actually takes away from the ability for industrial change and environmental change. It's a fascinating observation that Carl made, but he made an irrefutable connection between the environmental justice community and the workforce justice community, and how we won't be able to have the ideal development of a green economy without a skilled workforce and without some voice at work and democracy at work to contribute to the development of the industries. There are three things that I'm particularly concerned about, and that are that, and I hope that everybody thinks about as we help to shape here this portion of the new economy. And the first is that a carbon-free economy isn't necessarily going to be more democratic. It isn't necessarily going to be more fair than the existing carbon-based economy. Second, that there's no guarantee that a market-based cap and trade method will reduce greenhouse gases, protect jobs, and distribute revenues broadly and productively. There are some real challenges about this cap and trade system, and we need to really address them now. And let me also say that, in the spirit of what Carl Pope said, that the new green economy capitalists, the capital of the green economy, won't necessarily commit to good jobs and middle-class wages. And without that, as Carl Pope himself said, we will have failed. And so part of the challenge that we face is how we create this convergence, again, of environmental justice and industrial workforce justice. So that's what I hope that we'll leave you with as you explore these notions today. We have some really great thinkers that are both out there in the participatory audience and up here in terms of the presenters. So I hope that we will learn today how to bring together, the academy, environmental justice, unions, and business to think about how we build a much stronger economy in this new green economy, and it'll start here today. So, by the way, I also want to invite you all to a program that we have on May 27th and 28th in San Jose, which is called The Great Transition. And it's another look at how we prepare the workforce of the future for the new economy. So we hope that you have a really great, productive session today, and we hope that you think about how we take it from today to the future. Thank you very much.
Thanks a lot, Art. And now I have the pleasure of introducing Bob Balgenorth, the president of the State Building and Construction Trades Council of California. He has served in that position since 1993 and has been really an early leader on climate change policy and seen the opportunities for the construction trades in building this new green economy. Bob has a long history of building alliances with environmental groups, and he is actually in 2005 received the Brian Scheer Environmental Leadership Award from the California League of Conservation Voters, and he now serves on the board of the League of Conservation Voters. He's also a member of the California Workforce Investment Board and has a very active council in this right now. I know his folks are working really hard because I talk to them at 8 p.m., et cetera, and they're watching and making sure that the American Recovery Act funds are directed to really constructing and putting the down payment on the green economy, good jobs and green jobs. Bob.
Also the guy buying beer at noon.
Yeah, right.
Thank you very much and welcome. Now, Art is obviously does have the flu. He's got a severe fever and he's become delirious. And I don't know why he asked to shake my hand just before he started clearing his throat. As Carol said, for many years, the state building trades has been a crusader for environmental causes. We believe that cleaning up the environment is just very good for jobs. It creates a lot of work for construction workers, and it makes it helps to grow the economy. It creates the best of all worlds. More work, cleaner environment, better pay. So that's why we've been involved in it. The new green economy is talking a lot about that we need to do retraining. For at least 10 years, building trades unions have been preparing for this in a lot of ways before it was fashionable to call it that. And you might be surprised to know that building trades unions collectively spend over $100 million a year on training apprentices and retraining journeymen. That's labor management funds, but it's run primarily by the trade instructors, and it's what makes us the cutting edge of the industry. 92% of all apprentices go through a joint labor management apprenticeship program. So, the value of this conference is to the great diversity of speakers. You're going to have people here from labor unions, environmental groups, environmental justice groups, and a lot of other stakeholders. So we all have common interests that can be advanced most effectively by working together, and this is a good chance to work together and understand each other. We in the building trades have a long history of working with the environmental community. Matter of fact, the building trades, through a group we call CURE, has worked with environmentalists for the last 10 years to make sure that we have cleaner power plants. The power plants that we have worked to secure have the highest standards of any power plants in the country, and it was accomplished because of our working with environmental organizations to achieve that. And in the end, we also got good jobs. All those jobs were built union. Another good example is LEED, Leadership in Energy and Environmental Design, a voluntary program that rates buildings for their environmental friendliness. Now, we are of the opinion that LEED standards, the highest LEED standards, should be mandatory for all buildings in the state. One of our top priorities right now is to get Congress to pass a comprehensive clean energy plan. The American Clean Energy and Security Act is now before the House Energy and Commerce Committee. The plan will make America a leader for clean energy and development. It will develop new energy technologies, create American jobs, and strengthen our economy for years to come. It will increase the production of alternative energy, increase the efficiency of buildings and homes, and it will stimulate private investment in new technology and new industries. So to accomplish that, we're running media campaigns for this bill in districts of key members throughout the country. One of those is being run in Mary Bono Mac's district down in Palm Springs. So I'd just like to take a moment to play that video.
What happens to America if the clean energy economy is built by foreign countries? Today, the majority of our wind and solar equipment is built overseas. We're losing jobs at home, while other countries are getting further ahead.
I do not accept a future where the jobs and industries of tomorrow take root beyond our borders. It is time for America to lead again.
We can build an American clean energy economy, but construction doesn't start until Congress acts. Brought to you by America's building trade unions. We are ready to lead.
I like that ad because it clearly illustrates that we are all partners in the fight for clean energy and how we will all benefit in multiple ways. I'm proud that the State Building Trades is a co-sponsor of this conference because it will give us an opportunity to address carbon pricing policies, including direct regulations that will reduce carbon emissions, and how to design these policies to create new jobs. There are a lot of people that want the jobs just to be, as Art alluded to, low-wage jobs and don't even care about having them in this state. So we're working very hard to try to make sure that this new energy economy is one that will benefit all workers, and particularly workers in the state of California. So I won't belabor these points anymore because you have some incredible speakers here today, and you have some very good workshops. And I just wish you an extremely successful conference, and I hope that you will get together and meet with each other. Many of you don't know each other in this room, and this is a great opportunity to get together and learn from each other and form even better coalitions than we have before. So thank you very much for coming.
Hi, everybody. I'm Andrea Buffa from the UC Berkeley Labor Center, and I'm going to help kick off the opening plenary for the conference. This is the plenary that's going to set the stage for the rest of the conference, and what it's going to do is give us an overview of some of the key issues, an overview of the latest in the climate change science, an overview of the economic impact, both of climate change policies, but also of climate change, if we don't implement any policies to address it. And then finally, an overview of climate change policies that put a price on carbon, and that is cap and trade, also known as cap and invest, cap and dividend, and a carbon tax. I also, just as an aside, want to say, and Bob brought it up as well, that we're focusing at this conference on policies that put a price on carbon, but that doesn't mean we're not going to talk about other climate change policies as well. A lot of us are very enthusiastic about energy efficiency policies, about renewable energy policies and public transit policies. We'll be addressing those as well. But it's also really important because these policies that propose putting a price on carbon are being either about to be implemented or proposed at the state level, at the regional level, at the national level, and the international level, to really understand those policies and to understand the design options within them that can make a huge difference in terms not only of the environment, but also their impact on working people and on low-income people. So we want to address those things within this conference as well. I'm going to pull the computer up, take a deep breath, and then I'm going to introduce the speakers for our opening plenary. I also just wanted to say, if I forget, remind me at the end of this panel to let everybody know which rooms the workshops that are coming directly after this are going to be in, because it's not on your agenda, but we do actually know where they are, and we're going to direct you to them and just tell you a little bit about them so that you go to the one that you really want to go to. So the first speaker on this panel is going to be Payal Parekh. Payal is a climate campaigner for International Rivers, which is based here in Berkeley, where she raises awareness about the fact that dams are emitters of the powerful greenhouse gas methane. Payal holds a PhD in oceanography from MIT and the Woods Hole Oceanographic Institution. And Payal's going to be the person who's giving us an overview of the latest climate change science. The second speaker, right next to Payal, is Dan Kammen. Dan is the founding director of the Renewable and Appropriate Energy Laboratory at UC Berkeley. His work is highly interdisciplinary and includes technical, economic, social, policy, and environmental analysis and activism of energy production and use. His focus is on renewable energy policy, and development. And Dan's the one who's going to be giving us an overview of the impact of climate change on the economy, if we don't do anything about it, and the potential economic impact of climate change policies. And obviously, these are themes that we're going to be dealing with throughout this conference, and as we go through the day, we're going to get deeper and deeper into the details of these things as our knowledge of these issues becomes greater. And then our final speaker on the plenary will be Holmes Hummel, who's sitting at the end. Holmes has been recognized by the Environmental Leadership Program as a visionary, action-oriented, emerging leader. Holmes has taught at UC Berkeley in the Energy Resources Group and has also taught a popular Climate Policy Design Pro series for, I think, hundreds of people in the San Francisco Bay Area. As a Congressional Science Fellow, Holmes developed key climate change policy provisions that are now included in the national climate change legislation that was introduced by Representatives Markey and Waxman. And on this plenary, Holmes is the one who's going to be giving us an overview of the climate change policies that put a price on carbon. So we're going to start out with Payal. Come on up.
Okay, good morning. I'd like to thank Andrea for inviting me, and thanks for coming out in the rain. I heard that there was a 30-minute delay with Bart, so I'm glad that despite the fact many of you are here. So as Andrea said, I'm going to talk about the newest data related to climate change. And so the outline of my talk is I want to start out showing you evidence of climate change, and then hopefully I will convince you that humans are indeed responsible for these changes to climate that we've been observing. And then I want to look into the crystal ball and tell you what the projections are in terms of what our climate is likely to look like in the next 50 to 100 years. And lastly, I'd like to touch upon how we can avoid dangerous climate change, or what are the targets that we need to ensure that we stay beneath. Okay, let's start out with the evidence. Here, what I'm showing you is a plot of global average temperature over time. This is going from 1850 to the year 2000. And what you see here very clearly, especially starting in about 1910, that global average temperature, sorry, this pointer is having some problems, is clearly rising. And in fact, we know that temperature has already risen 0.75 degrees Celsius, which is about 1.3 degrees Fahrenheit since the start of the industrial period. And we are committed to at least a 1.2 degrees Celsius or a 2 degree Fahrenheit warming, and this is due to the emissions that we've already put into the atmosphere. And the next panel, we see something very similar for global sea level. We see that it is also increasing. And in fact, between 1961 to 1992, we see that the rate of increase was about 0.07 inches per year. And since 1993, this rate of increase has actually almost doubled. And then, of course, it follows that if the climate is getting warmer, that we expect that the area that is covered by snow to be decreasing. And here we're looking at snow cover in the northern hemisphere, but in actuality, it's also been observed that mountain glaciers as well as snow cover are declining in both the northern and southern hemisphere. So another crucial piece of evidence that climate change is occurring is the melting of ice sheets. And here I'm showing you a figure of the Antarctic ice sheet, and you can kind of think of ice sheet melting as the canary in the coal mine. Because it's what we notice here in this figure is we're looking at the change in the elevation level of the ice sheet. So in areas where it's red, the ice sheet is actually growing. Where it's yellow, it's staying stable. And if you focus in on this area, the West Antarctic ice sheet, we see actually that melting is occurring. And actually, scientists are quite concerned about this because in the last 2 years, we've realized that the melting is occurring at much faster rates than we predicted. And now if we take a look at Greenland, we see something similar. The yellow marked area is where between 1992 and 2002, the region that we observed was melting every year during the seasonal melt and the onset of spring. But in 2002, scientists observed that the area that's melting is actually increasing and moving further inland. Now, all of you probably have read the papers and heard about CO2 levels. I wanted to put the CO2 levels in context for you in terms of human history. You know, as humans, we live maybe 70 years, but the climate's been around a long time. And so what I'm showing you here are the atmospheric CO2 records from ice cores that were taken in Antarctica. Essentially, what happens in an ice core is that air bubbles from the past get trapped. And so starting from the left-hand side, this is 650,000 years ago, and we move all the way to the right, and that's today. And what we see in terms of atmospheric CO2 is today the level is at 378 parts per million, and that is about 100 parts per million higher than the Earth has experienced in the last 650,000 years. The other interesting point to notice here is you probably see the red and the blue wiggles. The red wiggles represent the temperature in Antarctica. You probably noticed that they follow one another, essentially that there's a correlation between the two. So this correlation wasn't lost on scientists, and scientists began to wonder if it's the increase in CO2 levels due to the burning of fossil fuel that is actually causing the observed increase in temperature. And so what scientists did is they used a climate model, and they wanted to see if they could actually reproduce this increase in temperature that we've seen in the last approximately 100 years. And when scientists in a model only account for natural variability, so there's some things in the climate that change naturally, such as the number of sunspots on the sun or volcanic eruptions, what they find is they cannot reproduce this increase in temperature that's happened in the last century. But the minute that scientists include human influences, primarily production of greenhouse gases, primarily CO2 as well as dust, we see very nicely that the model, which is the gray line, follows very carefully with the red line, which represents the observations. So I think this is a very powerful slide because it shows very clearly that CO2 is a major driver of the climate change that we are observing today. All right, so I've made it very clear, I hope, that it is in fact because of industrialization that we are having climate change. But in terms of what is going to happen for the future, it depends on the decisions we make in terms of emission pathways. And so here what I'm showing you is a plot that runs from 1900 to 2100, so into the future. And here are the possible, on the y-axis, the possible potential global surface warming that could occur. And these colored lines here represent different emission pathways or models of economic growth or development that we as a world can take. And so if we decide to follow the red line, which would essentially mean that we continue to emit high levels of carbon dioxide and other greenhouse gases, we can expect that temperature by the year 2100 will be fairly high, on the order of almost 7 degrees Fahrenheit. And the range here, which is this gray box, actually can go up to about 10 degrees Fahrenheit. On the other hand, if concentrations were to stabilize at the CO2 level of what we had in 2000, we see that relative to 2000, that temperature would increase maybe only about 1.5 degrees Fahrenheit. So these are clearly, we have some possibilities here to decide how far we are going to let the climate sway from natural conditions. Okay, I want to show you some projections to drive home this point that depending on how much we decide to emit, that there will be different outcomes. So here what I'm showing you is temperature projections from climate models for a low, medium, and high greenhouse gas emissions scenario. In the first case, if we look at what we can expect in terms of temperature projections for 2025, we see in all three scenarios that there is not much difference. But on the other hand, if we go towards the end of the century, we see that there is a huge difference between a low emission scenario and a high emission scenario. In the high emission scenario, you see that temperatures can be up to, for example, here in California, an increase of 7 degrees Fahrenheit, and in the very high latitude, over 10 degrees Fahrenheit. So if you could imagine that instead of, I think the average temperature in the Bay Area is perhaps 55 degrees Fahrenheit, that it would be 63 degrees. That's a huge difference. And that, of course, will also have effects on rainfall. And so here is again from a model which is giving projections of changes in rainfall that could occur if we follow a middle pathway in terms of emissions. And so what we see for the most part is that, and this is for, I think, for the year 2100, what we see is at very high latitudes, we will expect that rainfall will increase. But on the flip side, in dry regions such as the Sahara or Australia, you can expect that those regions will become even drier and therefore exacerbate a water shortage and drought conditions. So in terms of impacts, what we can expect is there will be coral bleaching, and the extent of it will matter as to how high temperature rises in the next century. We are already putting, and we will continue to put ecosystems at risk. And there are estimates that at 2 to 3 degrees Celsius increase, which is about, I think, 5 degrees Fahrenheit increase, that up to 30% of species could be at extreme risk for extinction. And we will have an increase in extreme weather events, such as extended droughts, as well as, the picture didn't show up, but it should be of flooding. And now if we take a closer look at impacts in our neck of the woods, looking at the Western North America, so the United States and Canada, as well as northern Mexico, we see, and this is a big issue for this area, that there will be decreased snowpack, which means there will potentially be more winter flooding but reduced summer flows, and it will essentially exacerbate the water shortages that we are already facing here in the state. We can also expect, especially for those living probably in Los Angeles, an increased number, intensity, and duration of heat waves. And lastly, the stress that coastal regions face will also be increased. Okay, so these are the potential projections. Everything that I showed you is very likely to happen, but what's important is to what extent will it happen? And that's going to rest on how much we as a society decide that we can pollute. And so I'm showing you these very new results that actually just came out on Thursday. And what a group of scientists said is, okay, we want to see how much can we pollute if we want to have a good chance of keeping global average temperature below 2 degrees Celsius. I should tell you that 2 degrees Celsius is 3.6 degrees Fahrenheit. It's actually a very arbitrary target. It doesn't mean that if we are below this, that we will not have any catastrophic effects. It's actually completely arbitrary, but it's about over 100 governments in the world have said, okay, we would like to work towards this target. And quite frankly, the countries that are most affected by climate change, the small island states, in December actually said, you know, this target should actually be 1.5 degrees. But what these scientists found is that between 2000 and 2050, we could emit 1,000 billion tons, which is equivalent to 1 trillion tons of CO2. And we would have a 75% chance of staying below 2 degrees Celsius. 75%, it sounds, it's like a passing mark in school. It sounds like not so bad. But it's important to remember that actually means that there's still 1 in 4 chance of going above this target. And I'd like to pose to you the question, would you board a bus if there was a 1 in 4 chance that the bus would have a crash? So as a society, we have to really think, it's not a scientific question, it's a political question. Are we willing to accept this amount of risk? And what the scientists have said is they show a potential emissions trajectory, and that's here in the top panel, this blue curve. And what they suggest is that we need to peak emissions between 2015 and 2020, because if we don't do it, if we do it after that, we will have major problems, it will cost a lot of money to bring down emissions in a short amount of time. And beyond that, we have to move to almost a carbon-free economy if we don't want to overstep this 2 degrees Celsius threshold. Now, for those of you that have maybe heard about talking about this stabilization concentration in the atmosphere of 350 ppm. This is what Dr. James Hansen has proposed, as well as others. And I believe there's an organization with an office here in the Bay Area called 350.org. What these scientists suggest, that means we can pollute 750 billion tons between 2000 and 2050. And so what that means is we improve greatly our chances of staying below 2 degrees Celsius if we were to limit pollution to 750 billion tons. The bad news is that already in the past 9 years, 2000 to 2009, we have already polluted approximately 300 billion tons. So what that means is we need to move fast if we want to really bring down emissions and have them peak at 2020, which is in 11 years. Okay, so in conclusion, climate change is happening. It's already happening. We can expect that there will be higher temperatures, sea level rise, changes in rainfall patterns, and more extreme weather events. On the other hand, we do have the ability to reduce greenhouse gas emissions with the potential of limiting warming to 3.6 degrees Fahrenheit. But the science is very clear that we need to reduce our emissions quite a lot and very quickly. But I'm going to leave it to my fellow panelists to talk about how we can build a political will and what are some technological as well as economic pathways that can lead us to limiting greenhouse gas emissions. So I thank you for your attention, and I look forward to the questions and discussion afterwards.
So our next speaker is Dan Kammen. And as Payal said, we're going to have questions and discussion at the end after all the speakers speak. We are going to have microphones out on the floor, even though we know that is dangerous in the Bay Area. So Dan, come on up.
Okay, well, I'd also like to add my welcome and pleasure to see you all here today. And I'd like to sort of be the bridging talk a little bit between where the climate science is, where some of the international discussions are, and then what'll be the bulk of today's conversation. And that's really how do we think about not only the job impacts, but the wider economic and political impacts of the types of more detailed policies that are embedded in the current bills and are in some of the bills that are being discussed. I was actually in Senator Specter's office an hour before he changed parties, and I must say he knows how to keep a secret, because it was a particularly quiet day in the office. He actually walked out, and he came out, we chatted for a bit while I was waiting for his climate staffer, went back in. His assistants were actually preparing invitations for a a meeting he was going to have in Western Pennsylvania. 40 minutes later, the announcement was made. So at least he knows how to do the politics of it well. And his office and a number of others are working on some climate bills that we'll get to later on that differ somewhat from the Waxman Markey and other pieces. So what I'm going to do is I'm going to start off with a little bit of what's happening in the clean energy sector, and then discuss a little bit of the international conversation, and then come back to the U.S. issues and some of the regional ones that really shape where we are today. So if I just start off with sort of what's the bit of good news, and I'm going to bring this from a talk we just gave at the World Bank on energy development with an Africa focus. These are the growth rates globally today for investment in a number of sectors. And so this is the compound annual growth rate in wind, in solar, in work on fuel cells, and work on ocean energy, in bioenergy, in efficiency, and then in the service sector. And on average, the growth rates are good. So if one is selective, you say, oh, this is very exciting. We have compound annual growth rates that are really ramping up dramatically. There's a number of good pieces of that story. There are certainly growing industries in essentially all of the technology spaces that we're going to need to draw on. There is bits or lots of good news. The wind industry, the solar thermal industry, the photovoltaics industry, the deep geothermal industries, energy efficiency, the one that unfortunately, well, I'll come back to it, but there's essentially a nice pattern of strong growth. And so there is not only a technology base, but also an economic base of these clean tech companies that one can really draw on to both make the case and implement the changes that we're going to have to get to that we've heard illustrated in the first talk. I do notice, though, as someone who tries to work on essentially all of these with a bit of a focus in wind and solar, that the lesson on energy efficiency has not been well learned. While all the areas show some action, the sector that A, enables many of the others, B, is the most shovel or wiring or conduit or drywall ready, and the one that, in fact, if you don't get efficiency right, it effectively doesn't matter how you do in the others. So we have sort of the classic mismatch of there's lots of exciting technologies. The one that may be said not in Berkeley, but is the most boring, is the one that facilitates the most and is not yet fully on the table. And there are really strong regional issues. I was highlighting this at Africa Day at the World Bank, highlighting what a tiny percentage of these growth technologies are actually taking place in the areas that are trying to build infrastructure the most quickly. There is no major wind companies in Africa, despite the fact that wind is growing by 20% per year worldwide. There is 2 essential solar companies in all of the continent of Africa actually building solar cells. So there's a regional disparity, but there is a technology base that one can all draw on. So there's a good start. So that's the good news. Let me now do the piece that connects more to the talk you just heard and highlight while the conversation in the United States has thankfully done an absolute about-face, as we heard in the opening comments from Art, after the election and the election of President Obama, which still is fun to say. But the global message is still very bleak in terms of connecting what we're doing and what the climate and what the wider political science says. If we talk about the types of limitations on emissions that the science community is saying, and I am currently the chair of the Intergovernmental Panel on Climate Change's Renewable Energy program. There's a series of chapters being written. Some of you may be involved in different aspects. I run the policy chapter right now. If we talk about the sorts of limitations that are consistent with the science, not necessarily with the politics, we get a global picture that looks more like this. This is done by a number of colleagues of our Shivan Kartha at TELUS in Boston, and Paul Baer at EcoEquity, and now at Georgia Tech University, a graduate of Berkeley. If I just highlight the sort of numbers that the science says, and that's on the order of a 2-degree or so maximum rise. Not a suggested recommended speed limit kind of thing where 75 is fine and 55 is the law, but one that's much more consistent with beyond the 2 to only a small bit larger increase in temperature, we will see truly dramatic changes, dwarfing some of the ones you saw actually in the previous slides. Divvying up the path that we're on, if you think about this kind of pathway, it unfortunately says that to leave any room for developing countries to grow, the sorts of emissions pathways that the science says are like the blue for the developed nations. Now, there are no bills being even discussed in the United States that do anything that even approximate the kind of path we see here, with essentially no more growth in emissions. It's just simply not on the table right now. And so, as exciting, as important as the discussion today is in terms of the Waxman-Markey bill, the features to get us going, and we have to get through that stage, it's critically important to know that the climate science is saying a much more dire story. And the types of cuts that we're going to need in emissions are not yet globally on the map. They're on the map in Norway, they're on the map in Austria, they're on the map in Humboldt County. They're not on the global agenda. And so I'll come back to that in a bit. But it's really critical to recognize that any growth in emissions in developing countries, which we're essentially committed to now, require policy changes and technology implementation that is far beyond what we're in conversation of right now. Another way to picture that is if we were to sort of divvy up who on the planet has the resources to invest anything in this, you get a picture that looks a bit like this, where if you put a threshold out for funds to meet basic needs, and then you look at what percentage of the population, just as 3 random countries chosen in India, China, and the United States, have an ability to invest beyond a minimum economic and resource threshold, there is a huge, huge need to think much more aggressively than anyone is doing in the open about the types of technology transitions and the types of investments in green jobs that we're going to need to actually get there. So my news is perhaps even worse than the climate news, because it says that while the climate story is one thing, we have an ability to ignore that one. To try to translate this into policy, we're going to have to find ways not to ignore it. Now, thankfully, the news isn't all bad. We do have places that are sort of on the charts, and as many of you know who've worked on AB 32 and a number of the other regional laws, we do have trajectories that are at least talking about the right order of magnitude. So California's AB 32 doesn't say cut emissions from our baseline, the 1990. It says over the next 11 years, get back to that baseline. And if you look not too closely at the graph, you'll notice that we are essentially at the needed peak year emission numbers already, the green curve, right? Well, California has great paperwork. We do have some impressive growth areas. We have not actually cut emissions yet. And so to talk about what will have to happen both at the US level and internationally, we're far from the types of changes we're going to have to see. In fact, if I go beyond the California story, which is heroic in itself, we do see some tremendous growth in technologies. Unfortunately, it's nowhere near enough. So we heard an opening comment that people critically matter in the process, and I certainly agree with that. The combination of people trying things and legislation that we work with is a critical part of the story. So if we look at what's happened in California, this is the installation rate of new solar and wind technology over the past several years. And many people were tremendously skeptical that AB 32 would make much difference. If you look at the 30 to 100 megawatts of new renewable energy installed in California up until 2007, when AB 32 was passed, I think one should at least, even the biggest skeptic has to recognize that good legislation can really jumpstart things. So California had a 5-fold increase, not 5%, but a 5-fold increase in solar and wind installations that somehow magically directly correlated with passage of our greenhouse gas law. It's an incredible start, and the numbers are even a little bit better if you look at the number of proposals and contracts in front of our Public Utilities Commission for review right now. There's over 3,000 megawatts of new solar and wind in front of the PUC for review and installation that's going on this year. And unfortunately, it won't happen due to a combination of the economic downturn and just not all projects move ahead. I certainly don't want to, do not ask me this again, yes. As that we have over 20,000 megawatts of new orders that have been proposed for 2010. Now, what fraction of those would get built? I would estimate it would be on the 10% level or so, similar to 2009. But what this says is a combination of an industry that's ready to go, legislation that really pushes things forward, can dramatically change the story. And California is a real example of that combination of the green tech sector ready to take off and legislation that enables it. And we have lots of examples. These are wind turbines, and these are in fact imported from Denmark, arriving in the port of Oakland. And so there's a story that we saw in the opening video from Mary Bono Mac's slides in terms of the technologies being imported, but the global industry is ready. The fact that we were asleep at the switch, not just for the 8 years of President Bush, but for a good chunk of the years before that as well. Unfortunately, we are way behind the curve in the technology in the manufacturing base. We are a great spot in the R&D base. If I take the California story and roll it up to the national scale, this is our historic emissions of greenhouse gases for the United States. We're at about 2 billion tons a year. Our business as usual plan is plotted in the dotted line, a path that we won't follow, thankfully now. The path that President Obama has put us on is the red line here, which does two critical things. One, the president's plan so far says we will return in 2050 back to the levels that the IPCC has said we need to hit. That's this 80% reduction. That's the same target as California has. A number of cities around the country, a number of other states have this 80% reduction target. California in AB 32 passes through the red box there that says a return to 1990 levels in 2020. There is not yet an Obama administration so-called midterm target to be negotiated, to be hopefully passed in Copenhagen in December, but something in this range is needed. And what's in this range? California has said 1990 levels by 2020. The European Union is discussing passing through this orange box, and that's 25 to 40% reduction by 2020 or 2025 to be negotiated at the meeting coming up in Copenhagen. And I want to highlight this because it does two critical things. One, it sets the proper endpoint, 80% or more reductions. Two, it highlights what some key players, California, the United States, and the EU, are talking about in terms of their ranges. And what's critical now is to marshal every bit of the technology base, of the potential for green job growth, to counteract what unfortunately is also going on. And this shows forecast and planned new coal plants around the world, highlighting China, economies in transition, OECD, and India. And what you note is that this curve alone essentially makes everything we've talked about impossible. If we build $1 trillion of new coal plants or more without carbon capture, we will essentially make that climate story impossible. And so the need to build these clean tech companies now and to deploy it is vital. And unfortunately, the momentum here is very large. We also have a similar story in terms of getting dirtier and dirtier oils from abroad, and there is, of course, a minor story on security issues that comes up when you look at things you can find on the streets of Berkeley. And in fact, right now, the potential alliance between the climate community and the security community is one that should take seriously because both of these play into the story. I will only flash them up so that they're in the slide deck for you all later on, but the growth of these technologies in poor developing countries is an impressive part of the story today. Kenya right now has the largest use of photovoltaics for electricity of any country on earth. Not the most power, but the most individual homes get their electricity from photovoltaics in Kenya than anywhere else. Done in an unsubsidized, very freewheeling rural market where the growth in the sales of very low-cost solar panels has been a dramatic change. It's the kind of thing that manufacturing in the United States, in Silicon Valley, in the Austin Basin, and Route 120 in Boston, can dramatically facilitate building jobs and at the same time dramatically replacing plans for dirty infrastructure with a clean one. And we've been studying the Kenya market for now 2 decades. It is spread virally to other countries in Africa following on this model. There are similar stories elsewhere. The efforts to build local grids using wind power and biofuels. This is an example from the Atlantic coast, the English-speaking coast of Nicaragua, where an NGO with a strong Berkeley tie, Blue Energy, has worked with a number of groups to both locally manufacture very low cost and very indigenously built wind turbines and build little mini grids, and they're finding dramatic success. It's a story you see in parts of South America, you see it in parts of Southeast Asia. They're the examples of what is coming. And the sort of thing that we have done over the past decade or so is to highlight these stories and in a bottom-up way to kind of quantify how much of a growth we've seen in these areas. And so starting in early 2001, we started working on a series of reports for the US Senate. Our first sort of major paper on this was in 2004, where we highlighted the job potential in the renewable energy area, again, not based on models, based on empirical observations of companies in the US and outside. And what we see are the kind of the standard numbers that many people quote today, and that is in the renewable energy area, you see a dramatic jobs dividend. In some cases, a factor of 4 to 5 times more jobs per dollar invested in renewable energy than in fossil fuels. It's about a factor of 5 for solar, about a factor of 2 and 3 for efficiency. It's about a factor of 2 for wind. So there really is a significant jobs benefit to get there. Now, where those jobs go, how many types of jobs we get, and what fraction of those are labor, are US-based, et cetera, is much of the discussion for today. But one wants to recognize that the global base for doing this is in fact there. And while this jobs dividend won't last forever, this jobs benefit per dollar invested is going to decline over time as these technologies mature. For the states and countries that act early, there really is a benefit to doing so. We will release our 3rd iteration of this report later this month at the World Business Summit on Climate Change. I thought I said I don't want to see this little picture again. At the World Business Summit, which is hopefully the interim step between the scientific summit that happened in March and the major negotiation, the COP15 summit in December, we'll have a huge collection of business leaders. The UN Secretary General and others will be there to really highlight these stories. And again, at that event, we will release our next version of this report that does a great deal more on local job creation in Southeast Asia, in Africa, looks at what's going on in the carbon capture fields, look what's going on in terms of nuclear, wind, et cetera. And we'll have versions of that report that can be available to any of you who are interested in just about 2 weeks' time when it gets released at the summit. So I'd like to stop there, and hopefully I've tried to set the stage a little bit for not only the needs base for doing this, but also what is the technology base, and again, some of the story on where these jobs can be created and how much of a benefit there really is to being the early actors to make this happen. Thank you very much.
I think I got it. I think I've got it right here.
Good morning. I am very, very pleased to be a part of this plenary session. I want to thank the organizers once again. It is an elusive opportunity to have such a cross-section of interests with us. I respect the time and the demands on the time of all the people who have chosen to be with us for this morning and for the whole day. And for my part of the plenary this morning, I have been charged with setting the stage with a number of very key questions about price-based policies, which is the purpose of the day together. So major topics like carbon tax, cap and trade, cap and dividend, how you spend revenues, and so on and so forth. That's what I'm going to try to cover here very quickly. All of these visual aids are available for your use online. So if you're a jockey on these issues and you think you can sleep right through it, see if these visual aids don't help you in actually making the case and sharing information with your colleagues and peers. You can find all of it if you search Google for climate policy design. It's the first search result for climate policy design on Google. These visual aids and others I will be presenting at 2 different sessions today will be posted under the recent posts. So the 4 areas that we will cover just now is the purpose of a price-based policy, who pays for a carbon price, how much do people pay, and who decides, and what's the spending plan. So I'm going to start with the purpose. This is the only slide that's stacked with text, so bear with, the illustrations follow. The basic logic behind price-based policies, which I want to reiterate Andrea's earlier disclaimer, is not necessarily our first choice, but it may be an essential part of a policy platform to address climate change. We have to ask the questions, why are people using fossil fuels? And a pragmatist's perspective is, well, the benefit of the work produced from those products exceeds the burden that individual users bear for their consumption. We go to the gas station and buy gasoline because the benefit we get versus the cost we pay for it is greater. And we continue to buy gasoline until that's not true. But consumers, including companies, because we have industrial consumers, don't pay for climate change damages. They use the sky as a free sewer and jeopardize all life on Earth, the way that Payal described. This is a serious and arresting perspective that causes us to reconsider the use of the sky as a free sewer. As a result, the private costs of our consumption of fossil fuels are far less than the actual social costs. And Dan gave you the case for why there's a justice perspective on that, that actually the social cost borne by people in developing countries is even greater than that here in the United States. And that puts additional burden on the Americans to come to the table. When climate change damages are externalized from fossil fuel prices, society is basically subsidizing fossil fuel users by setting the price of pollution at zero. So we have to start at a very first step. Do we believe that polluting the sky should be free? Should the pollution price be zero? If you believe that it should be zero, you go along a whole nother track of negotiation around policy and what to do about climate change. If you don't believe the price should be zero, then you're faced with the questions, well, what should the price be? How do we add a price to pollution so that people who trade in fossil fuels and other things that produce greenhouse gases internalize the full cost of climate change and climate risks that they impose on the rest of us and people around the world? I hope this is a very useful frame for thinking about why we have to actually step to the question of what is an appropriate price on carbon dioxide. The purpose of the price-based policy, then, is to change people's choices so that we move toward a clean energy economy as a least cost option that is in society's best interest. That's the purpose of a price-based climate policy. The basic theory and rationale of it is that as we want greenhouse gas emissions to be reduced over time, we have a rising price signal that discourages people from engaging in polluting behavior. This is a 100-year time span, a theoretical projection of what it could be like to achieve stabilization for greenhouse gas emissions in our atmosphere using a price-based policy. But on the right-hand side, I've put question marks. What is the price on carbon that would give us this kind of trajectory of a declining greenhouse gas emissions profile for the rest of all of our careers? The first question to ask is, how far do we want to reduce demand for pollution? And the second question is, then how high should the price be in order to reduce that quantity of pollution? So let me repeat that. If you listen to Payal's presentation and you said, gosh, we just don't want that kind of future, you have to ask yourself, what is the appropriate target? So this is where the whole debate about targets come in. The first question is, how far do we reduce our emissions? And then the second question related to price-based policies is, then how high does the price have to be to discourage people from polluting fast enough to reach those targets? The choice of quantity, therefore, affects the optimal price, or the carbon price at which people will actually respond and change their behavior, change their investment choices. So who should decide what that price is and how? That is where proponents of a tax and cap and trade diverge. Up until now, they've had identical lines of logic. They get to the question of who should decide what the carbon price should be and how should they decide. This is where carbon tax proponents and cap and trade proponents diverge. So let's continue actually on the path that they share about who pays, because there actually is even more territory where they agree. This is a diagram that shows greenhouse gas emissions for our American economy. Who has the pointer, by the way? Well, I think I stole it. Let me just wave. On the left-hand side are the sectors of economy. Go ahead. Thanks. Over here are the sectors of the economy, where you can see transportation, about 30% of our greenhouse gas emissions, electricity, about 40%. This is natural gas. We're running low on batteries. Natural gas from residential and consumers is next, followed by industry. Now, on the right-hand side, you can see that the bulk of our greenhouse gas emissions are from carbon dioxide. So hopefully that makes this crazy-looking diagram make sense to you. And now let me just show you what's happening. So the Regional Greenhouse Gas Initiative is a cap and trade program started by 11 New England states that agreed to start with electricity only. They put a cap, and frankly, a weak cap, on electricity and the electric power sector only. And they capped emissions there, and that created a price for carbon for them in their market. Nationally, we have a different perspective, which is that in order to actually meet our national targets, we need a broader coverage. Coverage is a vocabulary term that's important to the definition of price-based policies. What do you cover? Price-based policies can only cover sectors in which greenhouse gases can be reliably measured, reported, and verified. This is why the agricultural sector is routinely excluded from cap and trade programs, because it's very difficult to measure, report, and verify greenhouse gas emissions from agricultural sector polluters, for instance, but not other industrial polluters for which there are smokestacks, and we can measure, verify, and report their emissions. So this is what a cap looks like from a national policy perspective. What about what's left? Oh, those are the offsets. The supply of potential reductions in greenhouse gases that could be achieved outside of the cap and counted towards progress inside the cap. I'm going to be discussing offsets later in the panel just after this. It's the last I'm going to say about a controversial topic on cap and trade, but you're welcome to pursue it in Q&A or at 10:30. The next question that both tax and trade advocates have to address is who pays at what point? At what point in the supply chain of fossil fuels in particular do we actually say ante up and pay? This is a picture of the supply chain for fossil fuels from the left, fuel extraction, down to the right, those of us who pay our utility bills, or consumers. We have to make a choice at which point we come and collect money and say, here's where we charge you for using the greenhouse gases, using the atmosphere as a sewer for greenhouse gases. For oil and gas, the point of regulation is essentially fuel processing and distribution. That's refineries, the point at which gasoline leaves the gate from the Richmond refinery, or the point of distribution for natural gas, that's when PG&E has natural gas and it's about to sell it to customers. Power plants and industrial polluters are the choice of point of regulation for electricity and on-site emissions. Power plants already report greenhouse gas pollution every 60 minutes to the EPA automatically. And there's only 1,500 power plants in the country that matter. They make up more than 99% of the greenhouse gas pollution from that sector. That is why we choose a downstream point of regulation for electric power sector. For industrial polluters, there are only a very few industrial pollution sources that would qualify as large enough to be regulated under a cap, and all of them are already covered under the Clean Air Act, already reporting their emissions routinely, literally hourly. That's why they are named as points of regulation. The purpose of a price-based policy is to have it affect as many purchases as possible all the way down to consumers. It is not a service to humanity to shield consumers from the price of their pollution. That's the point of the policy. It's not helpful, and it doesn't advance the cause for social justice to actually try to subsidize consumers to prevent them from seeing the price. It is important, however, to maintain household budgets for working class families. And I'm going to come back to that point when I talk about the spending plan. So, who pays? To close this section, I want to point out that all of the following policy design decisions are necessary, whether you care that the price is established by a tax or a cap and trade system. Which greenhouse gases would be subject, what part of the economy is in the scope, what's the point of regulation along the line of fossil fuel production and consumption, and who are the covered entities. If anyone tries to tell you that a carbon tax is really much simpler, we should give up this cap and trade thing, it's too complicated, let me assure you all of these same political battles have to be fought for a carbon tax. It's not that much of a shortcut politically to come to a carbon tax. So the big wrangle, how much? What is the appropriate carbon price and who decides? I'm going to use a little bit of Econ 101, which I hope will be helpful. On the horizontal axis, we have the quantity of allowed emissions, and on the vertical axis, the price of carbon. If you went to the farmer's market and wanted to buy a certain number of carrots, you might follow a similar kind of logic that I will now describe. Your demand is proportional, or it's relative to your quantity. Your price that you're willing to pay is proportional to your quantity, meaning that if I said, look, I've got 50 units of stuff and they're $50 a piece, you'll say, okay, I'll take 50 of those. But if I told you, hey, bargain, basement bargain, today the price is 20, you say, maybe I'll take twice as many today. This is a basic plotting of a demand curve. We can do this for just about anything you buy, from t-shirts to Cheerios. Same thing for supply. The suppliers will basically say, well, if you're going to pay me $20, I'll make 50 widgets. Hey, but if you pay me $50, I'll give you 100. This is the basic Econ 101 premise that works at every farmer's market you may ever go to buy, bargain, or haggle over anything. And it is exactly where demand crosses supply that we find market prices. So the question resolves back to, how do we define what a carbon price would be? Both a tax and cap and trade depend on markets. Let me show you how. The difference between the carbon cap and the carbon tax is that the carbon cap makes the quantity of allowed emissions fixed. That means that the yellow line, oh gosh, I did it backwards, so I'll do this one. The yellow line is vertical, meaning the quantity is fixed. The United States government says, look, this is the fixed amount that we are going to allow ourselves to pollute the sky this year. And now it is up to you, consumers, to decide how much you are willing to pay in order to buy the necessary reductions for us to meet that cap. Alternatively, if we want a tax, the United States government says, okay, folks, here is the maximum amount of money that we are willing to collect or make you pay for pollution, and you are welcome to pollute as much as you want as long as you're willing to pay this price. The contrast between these two things is exactly the difference between a carbon tax policy and a cap and trade policy. And it gets down to a fundamental philosophical conversation about risk, where risk is actually based on two factors: the likelihood that something will happen and the consequence that will happen. So let me pose these two questions. Should we let the government set the quantity and have us use markets to determine the price for a scarce resource? Or should we set the price via government and let the markets determine the quantity? Carbon tax is still a market-based mechanism for determining how much pollution we pollute. There is no such thing as a non-market-based tax. The market will determine how much we pollute if we set the price. Because we have a risk exposure to climate change, we have to ask ourselves then which of these two pictures poses us with more risk exposure, poses more of a risk to society. On the left-hand side, the risk that we face with a carbon cap is that we might actually set the cap too tight, and therefore the price would be too high. That's the political risk. I should say, what's the political risk? So the political risk is that the cap might be set too tight and the price will be too high. This is the anxiety that populists in America do bring to our attention. Oh my goodness, what happens if the price is too high? If the price is too high, we lose control of the policy and we're worse off than we started. So we have to ask ourselves, what is the chance that the United States government is going to set a target that is too tight? Okay, let's do the converse question. On the right-hand side, the risk that we face with the cap is that the tax will be set too low and the quantity of pollution will be too high. As a result, we'll be facing catastrophic climate risk. What are the chances that the United States government is going to set a tax that is too low to meet an aggressive target like Payal and Dan told us is necessary? 100%.
That was easy.
This is why people who have looked at the issue come back over and over again to cap and trade as a preferred alternative to a carbon tax. I know it's not necessarily comfortable for people who aren't very big fans of tax policy, but this is the line of logic. It's about risk management for society and planet Earth. This is the line of logic that you can review on your own. I need to continue to illustrate for you all how then a cap and trade program sets a price on carbon. Basically, I use the analogy of musical chairs for managed scarcity. It was my first introduction, and every 6-year-old can recognize the game. Basically, if you have an allowance, you have a chair. You name who the polluters are that are at the points of regulation. Here I've given you a sample. The government establishes a declining cap that's announced in advance. They take away a certain number of allowances each year so less pollution is allowed. And the polluters basically compete then to grab on to the available chairs. And at the end of each round, somebody is out a chair. This happens to be the largest polluter in the electric power sector in the United States. Out one chair, 1 ton. What will it do? It will have to decide for itself whether to invest in its own innovation or pay somebody else to invest in their innovation. AEP here says, well, I'm going to buy a permit or I'm going to reduce my own emissions. It puts a bid out to the market. I'll pay $40 for somebody's chair. Who will get up for $40? Duke Power says, sure, no problem. I've got a wind power plant in Kansas that I can actually buy for $40 a ton avoided. You can have my chair. I'll have your cash. Thanks. And that sets the market price for carbon. For $40, by the way, here are the retail price impacts that we could expect for the kinds of things that we buy as consumers. I want to keep moving because I've been given the 3-minute mark and I might have to blow it, Andrea, I'm sorry, but I want to get to the spending plan because people will want to argue about it, as we should. The government is considered a proxy for society in almost all of our policies. That's another philosophical and ideological difference that people can have about what the role of government is. But nevertheless, if the government is rounding up lots of cash, we have to decide how to spend it. Some of the things that tax and trade people share in common is that we have to decide who will collect the money, how will they collect the money, who will enforce against cheaters, what will be their method of detecting cheaters, what will the penalty be for cheaters. Tax and trade people also have to ask those same questions and answer them. But then we get to how will the money be spent. Well, they're actually also not that different. Once you have a big chunk of money together, you still have to answer the question the same. So tax and traders come back together again about spending. Extreme inequality in America makes this a major social justice issue. Right here, I am showing you the distribution of wealth in America before the Bush tax cuts made it even worse. And this shows us that 90% of the households in America altogether, if they combined all of their real estate deeds, cars, college savings, and everything, put it in a wheelbarrow and dumped it in the front yard, would have less than 1/3 of all the wealth in America. That's 90% of our families. 10% of our families control 2/3 of the wealth in this country. As a result of this matter-of-fact realization, any carbon price is a regressive tax on Americans unless there is a progressive spending plan that goes with it. Obama's budget chief is counting on $75 billion in annual carbon revenue, but it doesn't come out of thin air. It's not free, it's not new money. It comes out of people's wallets. Therefore, the effect of a carbon price induced by either a cap or a tax does depend on how the money is spent. Here are our options. Uncle Sam puts a cap on greenhouse gas emissions because it's good for society and it's good for the planet, but then it hands out free pollution allowances. When it hands out free pollution allowances to polluters, that is a transfer of wealth from taxpayers of America to the polluters. This is heatedly objected to by environmentalists and budget analysts. So as a result, people talk about cap and auction, where Uncle Sam sells the permission to pollute, and polluters have to pay to the American people some amount of money that the Americans then turn around and get to spend. So the question is, who gets the money? Uncle Sam then can give it to consumers. That's cap and dividend. But some people think that Americans won't spend their money very well, and in fact, there are important policies to pay for that will allow us to invest in a clean energy economy faster. Green jobs proponents are big advocates of cap and invest. And then, of course, we have obligations to international families around the world who will be suffering the largest burdens of climate change, and we do have to make a serious offering at the table in Copenhagen for financing, technology transfer, and capacity building. So these are the demands and the divvying up of Solomon's baby for the spending plan. So I'm closing now. To recap, here are some of the thorny issues that cap and trade people alone need to be able to answer to American people and the policymakers. How will the allowances be distributed? What will be the terms of offsets allowed? Will there be banking and borrowing terms? And how will we control the price to keep it from spiking or crashing? The tax folks have two very difficult questions to answer themselves. How in the world will we update the tax value when taxes are such a politically toxic topic every year? And what regulations will we combine with a tax to make sure that we actually meet our obligations, to meet our cap? Because the tax won't guarantee it. But both of them leave every room with the same burden, agreeing on the target, who has to pay, and how to catch violators, and how to deal with competitiveness concerns that are unique to very energy-intensive industries subject to global competition. I'll be speaking on that this afternoon. These are the major cap and trade systems that are already under development and underway, and I'll be speaking about those in our next session. And this is the California plan for AB 32. I just want to make a closing point that cap and trade is not everything, neither is a carbon tax. It's one element in a larger platform. More than 3/4 of all of the reduction in greenhouse gas emissions in California that are anticipated by AB 32 come from something other than a price-based policy. Nevertheless, price-based policies are an essential component, and here you see the role that the California Air Resources Board anticipates it to play. I appreciate your time. You can find all of this information in the visual aids online, and I'll welcome questions with the rest of our excellent panelists. Thank you.
All of you, that was an amazing amount of information, really excellent presentations. Do we have volunteers who are helping out with the microphones? If you are, come on up here, and I guess we should pull out those microphones. So we're going to do questions and discussion now. If you have comments, if you could keep them to 2 minutes or under, that would be lovely. We have about 10 minutes with a bit of flexibility for questions and discussion. If you want to ask a question or make a comment, please come up to one of the microphones. And while you're doing that, I'm just going to kick it off and ask a question of any of the panelists that want to respond. The topic of this conference is making climate change policy work in a difficult economy. And some of the strongest arguments against climate change policies right now are that they're going to hurt the economy and can't be done right now because of the economic downturn. What do you say about this argument? Is there any validity in that argument? Should the climate change policies being proposed be any different because of the current economic crisis?
Well, I think that the best answer to this is when's the best day to invest? It was 20 years ago. When's the next best day? And that's today.
Can you hear him?
Sorry, close the mic. Okay. So, I think the answer to that is really what's the best day to invest? It was 20 years ago. And the second best day is today. No question it will cost money. But it's also quite clear from the trends that the global investment in the clean energy sector has been rising, and politically in the United States, we have been falling behind, despite the fact that many of those technologies were actually invented here. So if we are going to follow the Rahm Emanuel, the never waste a good crisis quote, this is certainly a good time to do so. And even beyond the politics of it, it's pretty clear that the energy economy globally is growing fast enough in terms of new innovations that it would be bad economic policy, irrespective of climate or of the current downturn, not to want to play a big role in it. So there's plenty of good arguments at the general level and at the more detailed level of jobs in individual districts to argue that one should be investing in it now. Now, the problem is, of course, that by having been inactive on this issue for arguably 20 years, we're trying to undo something or to get back on the bandwagon for something that we have wasted a huge amount of time, not just time itself and money, but also the requirement that it takes years to build some of these companies. And so this is on a fast track. And what that means, of course, is that we are going to make some mistakes. So not every single dollar, I hate to break it to you guys, of the stimulus money spent on energy will have a 5 times return. But there's almost no argument for waiting given where the global economy is going, given the need to invest in this area, and given the fact that the climate imperative is out there. And as much as one wants to argue about which session of Congress and how many votes there are, the climate story doesn't really give a damn about which country or which congressman or which senator or which congresswoman gets the credit. And so I think there's arguments up and down the value chain to do this. And since the money is already on the table, and it's arguably enough to jumpstart the process, the $100 or so billion that will go into energy, irrespective of whether we do good or bad on climate change, is there and should be spent. And so, you can argue about if we had 10 more years, we could do it more slowly, how might you do it? All those are good arguments, but given where we are today, there's really not much of an argument not to do it. But I want to let Holmes weigh in on this as well.
Thanks. 3 very quick rebuttals. 1 is that if you're going to recover the economy, don't recover the one you used to have if you're trying to build a new one instead. Number 2 is that we are funding this recovery with money we have borrowed from our children. Build them what they need. They own it. They are our lenders. They have oversight and they are watching. Don't misspend their money and make them pay twice for mistakes we can already recognize today. And number 3, as Art said earlier, working families actually are most exposed to climate risks and climate burdens, the cost of transition in the United States. If we are already going to be spending, quote, recovery money, we should actually have a progressive spending plan for the recovery as well as a progressive spending plan for a carbon price. Any progressive spending plan for either the recovery or for a carbon tax or tap and trade program will actually have a beneficial effect on all working families and accelerate their path to prosperity. The people who are most concerned and most vocal about the economic impacts are actually members of the shareholding class in that top 10% of households and the people who work for them. And I think that's a really important analysis to have about the voices you hear.
So at the last G20 meeting, there was 2 policies that were put forward. One was more around financial regulation, coming out of Germany and France. The other was global Green New Deal coming, I think the UN, US, UK were behind that. A report came out this morning from McKinsey saying that $100 billion would support that global Green New Deal. And curious what kind of public-private partnerships might be put in place to support that, if that's large pension funds, series and groups like that that might participate with governments in putting investment into the developing world to bypass some of the carbon development process.
So Holmes looked at me like, all right. So I think that this touches on a whole bunch of things all at once. One is that we are not ramped up to do kind of high power financing on green deals yet. And that's not because they're that different than other areas. It's that the people in them don't have a lot of gut feeling experience with these technologies. Now, the gut feeling experience of our financial sector has not exactly proven to be a really useful skill in the last 2 years. But the fact is, no matter how many models and graphs you show, it's the gut feeling of investors that will, in the end of the day, be the determining factor for where the money goes. It's not how pretty the view graphs are, it's not the details of the process, it's will the money move in Wall Street, in London, in Zurich, et cetera. So getting familiar with these opportunities fast is a critical part of which of these go forward. And I don't think it's a choice between kind of the Germany, France versus the other perspectives. All of these are going to appear in the markets. The kind of thing that I would like to see, and I think we need to see to support the progressive green economy, redistributive view that Holmes talked about, are the kind of thing that we've been actually doing in Berkeley and has actually spread pretty quickly. So a year and a half ago, we had no particular unique plan to find a new financing tool. Now, Berkeley, 4 other cities in California, 10 different states now have passed versions of something which I skipped just to give more space for Holmes' great slides, and that is Berkeley started something called a municipal financing district. And it's incredibly silly and simple idea that we haven't done, and that's the silly part. And what it says is that if you want to allow homeowners, property owners to invest in green products, whether it's efficiency or renewables, you should actually make it easier. And so what Berkeley started was to say, we will lend you the money to invest in these things, and then you pay it back with an added property tax payment. Now, it's a very simple idea. Municipal financing is the old term. Now the new one I like much better is called PACE. That's property assessed clean energy. It's now sort of all over the map across the nation. Congressman Von Hollen from Maryland has introduced a $10 billion bill to essentially set up a federal revolving fund to fund cities and states that want to do it. And it's exactly the kind of thing that brings financing clean energy, both efficiency and renewables, directly to the people who use it. But notice, that even this, I think, amazingly good idea fails one of the key tests that was just highlighted. And that is, this version requires you to be a property holder. It's an amazing innovation for those who already have property, right? That has a clear wealth equity divide in this country. And so finding ways to either do programs that are covering the energy bills of poor individuals, of struggling startup companies, has got to happen as an added innovation. Or another way to say it is this kind of program has to be broadened to make it more equitable. But these are the kinds of ideas that we're going to rapidly need not just discussions at conferences about, but rapid deployment. Because essentially between now and the Copenhagen conference, there has to be a couple things that happen all at once. There has to be enough experience in the banking sector and at the local financial sector to highlight there's enough opportunities to make these things happen. There has to be clear action on a bill in the United States, and that's only going to happen if there's enough local experience. So yeah, I think we can see how we will profit in going green or greener. And there's got to be a long-run energy and climate plan that reflects the financial realities of moving the money. And so all of these relate to this question. They all relate to adding up an experience base around the most economically efficient ways to go green. Because whichever of the climate plans wins out, it all really doesn't matter. It's all sort of deck chairs on the Titanic unless you get money moving into these areas. That's really the critical part of the story.
Okay, so this is what we're going to do. Since we only have about 5 more minutes before we need to go into the next workshops, and I want as many people's voices to be heard as possible, we're just going to hear from everybody that's lined up here, get your questions or comments, and then we can get a response from the speakers, and then we'll do the same on this side, and then I'll tell you about where the next workshops are going to be. Okay, thanks.
Good, thanks. Hi. I can tell that this is a really different kind of a meeting, where the meetings I go to, a bunch of us communists and socialists and all those people get together and the lines are, out the door. What it is, I think, is that we've been struck by, we've all been told that the world is dying of cancer. And I don't know if you've had that happen to you, I've had it happen to me, and we're constantly playing with trying to cure, prolong its life in the face of what we think is really its death as we know it. And I think that shuts us up. This thing about the social, the political, the economic, as though the economy has a life of its own, I see that as a holy trinity, WHOL, and we can talk about the whole thing. We're not able to talk about the whole thing. And so that's the question. We have all the technology to deal with what's wrong, and we're not able to because of the economics of it. So if you get a chance, maybe not here, but later, for us to talk about what is the economic situation that allows us to hold Earth for future people that might enjoy it instead of have to suffer through the horrors that have been committed on it.
Thanks. Okay, and the next person.
Yeah, I just had a question, which was, what do you see as the role of nuclear and hydro electricity, and especially with hydro, how you distinguish between small and large hydro?
Okay.
Let's just go ahead and get them all in.
All right, everybody's questions, go for it.
Thank you. At these presentations, I'm constantly struck by the gap between what the science says we need to do and what the policies are that are out on the table. And I've asked this question before, and I know we don't necessarily have a good answer for this, and Dan, I put you on the spot with this question before, but I don't ask it again to be obnoxious. I think we need to keep asking it until we have a good answer. What sort of goals do we need to be setting at the national level, but also within our cities and counties, in order to reduce emissions to the levels they need to be reduced to? For example, 350 parts per million. What are the reduction targets we need to be setting in our cities and counties and nationally in order to do that?
Yep. Thanks. Mine is a little bit more of a comment. I just wanted to say I definitely heard all of you kind of echo the idea that the science creates the need for a political will and some courage. So with that in mind, I wanted to challenge the notion that we can't regulate polluting industries like ag. I come from the Central Valley. I'm a recent refugee from there because of air quality issues for my young son. And so my comment and my challenge to you up there, but also to all of us here, is to really bring together our unique perspectives and experiences, and to look at the co-benefits and to support the development of policies that look for co-benefits. This approach also addresses concerns that I have as an environmental justice advocate, but it's also to keep each other abreast of new science. We know now that dairies and other CAFOs, which have been long-term enemies to air quality for environmental justice communities, also emit greenhouse gases. We also know that those greenhouse gases can be reliably measured, reported, and verified. We also know now that toxic fumigants, which are more likely to drift into EJ communities and cause serious health effects, are also basically sterilants of the earth and are creating an inability in the ground in the Central Valley to be carbon sequesters. So I just wanted to make that known that we do have this science available now. This does mean that we have the responsibility to regulate polluters, and that's a challenge for all of us today. Thank you.
The focus of this conference is carbon tax and cap and trade, and I wonder if you can also address the role of regulation. There was a study by the World Bank.
Excuse me, we can't hear you. Can you say that again? Sorry.
Okay. What was your tax and trade, and what was the third one? Let me just start over. There was a study in 2006 by the World Bank in terms of emissions credits trading of HFC 23, which is a greenhouse gas emitted by the refrigerant industry, and the emissions trading emissions trading for that greenhouse gas as of 2006 has yielded US $5.9 billion. Meanwhile, worldwide reduction, the total worldwide cost of installing chemical scrubbers to halt the emissions of gases is only $100 million. So the trading to stop it is 500 times more than the actual cost. And so the cap and trade seems to be the key, the keystone of Obama's policy when regulation can do a much more effective job. And so I'm wondering whether or not you can address that, or whether any of the workshops will be addressing that.
I can take the last two.
Yeah, forward. Sure.
Yeah. Okay. The four questions I heard are: what about nuclear and hydro? What rules at the national and local state will actually get us where we need to go? What about ag? And what about the HFCs and the difference between cost and value? I'm going to take those in reverse. The HFCs question is actually on the table today in the White House in a duel between the Economic Council and the Energy and Climate Council in the White House. The question is about the difference between cost and value. The value of the reductions of the HFCs is 5-point-some billion. The cost was 100 million. The huge difference between those is the argument for why we should extract the HFCs and other super greenhouse gases away from cap and trade and regulate them separately with probably a lot of command and control, and not this trading and value of abatement stuff. So HFCs is a slice of the problem. We don't talk about it in the plenary. I'll be happy to talk about it later. The second thing about ag and offsets, I wanted to be clear about why agriculture is excluded from a price-based policy. Not excluded from climate policy, but excluded from the price-based policy. And that, in fact, there are important reasons to include agriculture as a source of offsets, because it's an affordable way to actually meet obligations inside the cap if you are able to find ways to reduce emissions outside the cap. And that's a very important part of the story for Central Valley farmers and ranchers in California. As far as national level and local and state level targets and regulations, I would like to endorse the following concept as a target, and that is maximum sustained effort. At any point, any person with social authority, from the family to the congregation, city council, state legislature, and the President of the United States, is not using their maximum capability to reduce greenhouse gases, we are not meeting our target. That's essentially the long-term duration of the pressure. As far as local and state concerned, I'm interested in seeing the renewable electricity standard passed at the national level as a start, a moratorium on new coal power plants, and a number of measures that will help us in the transportation sector over the long term.
So just very quickly to highlight a number of the interesting questions that were asked. I think one of them is that California, as an example of a number of places, have actually found ways to tackle some of these numbers that relate to ag and various issues. One example is the low carbon fuel standard that we and others wrote in 2006. The governor signed it in 2007. The Air Resources Board passed it a week and a half ago. And that basically said regulate fuels based on their greenhouse gas content. But look at the life cycle of that. And the life cycle also involves the ecological impacts, the water impacts. It's a broad story. And so there are sort of what I would call organic policies, meaning policies that evolve to meet the growing challenges of regulation that get greenhouse gases squarely in front of economic policymakers, businesses at a whole variety of levels. So there are tools that are evolving, and actually the White House already has the low carbon fuel standard on its website. So there are versions of this story that evolve from the starting grounds, the basic idea to protect climate. I think the other feature which is worth sort of noting from the comments we heard is that there are these technologies that are available. And while I'm a huge fan of the technologies, I think the statement that we have all the technologies we need is actually false. And it's not false in some theoretical world where you have infinite technology, infinite money, infinite ability to do things. In terms of technologies we can deploy at scale that are reasonably affordable today, that's actually not the case. President Obama has said very clearly we need a combination of a research and development plan and a deployment plan. We have been incredibly lax on both. We've arguably been more lax on deployment than research over the last few years. We need to deploy rapidly with a kind of Holmes' maximum sustainable effort view, because this is a marathon and not a sprint. Right? A 2012 goal, a 2020 goal is nothing but a mile marker along the way to this 2050 or more goal. And we try to be very clear about what those numbers are. It's somewhere between 350 and 450 parts per million. And by the way, we're beyond the 350 right now already that the climate goal says we need to get into. Now, that is not a reason to throw up one's hands. The fact that we are already above the first thresholds now doesn't say we should only look for a bill that perfectly gets us to the final goal. We're going to have to build this up over time. But we've got a lot of the pieces to get going, and I think the maximum sustainable effort idea is an example of sort of how would you direct a policymaker. But it's all of these specific regulations that cities do, that states do, that we're seeing in the debate over the bills, that's a critical part of the story. Hydro and nuclear at all scales, small to large, are likely to have a role. People's politics on them vary dramatically, and the cost effectiveness of them varies dramatically. There are big downsides for hydro at different levels, as everyone in the room knows. Same is true for nuclear. We are likely, however, to need all of the low carbon technologies to be given a really serious kick the tires, if not deployment, to find out which ones work. Because what works in the lab, what works in practice, doesn't always match up. We did a 60 Minutes this past Sunday on carbon capture and storage, something that got $20 million here at Berkeley 2 weeks ago, but it's one that a huge range of the scholars are deeply skeptical that it will be able to be deployed in any reasonable way. But we're likely to need to kick the tires on all of these to meet these climate goals. So I know I'm over and I'll stop, but thank you very much for the quick rapid fire last bit.
Okay, so first, let's give a round of applause for these great panelists.